Okay, so what I want to finally go over is how to do the last two problems that I assigned for homework 10. Um, and they're actually pretty easy problems. I think definitely one of the easier exam FM type problems you'll get. So I'm not doing them exactly. I did make some modifications to the problems, but nothing too creative, you know, because you don't have much time to really, soak in a vastly different problem. Okay, so the problem is 522. The numbers are changed a little bit. You're given the following information here. You're given that the time-weighted return is 1% and the dollar-weighted return is y. Calculate y. Okay, so the basic idea of this problem is just use the definition, really, of the time-weighted return and the dollar-weighted return. And in particular, for the time-weighted return for this problem and 524, you just use the formula that the growth factor for a period is the amount at the end of the period before deposit or withdrawal divided by the amount at the beginning of the period after a deposit or withdrawal. Right? Again, remember the logic is, you have at the beginning of the period, you make a deposit or withdrawal, and then money sits in the account untouched until the next deposit at the end of the period or withdrawal if there is one. There might not be one at the beginning, but the point is we're trying to look at the growth factor in between the deposits and withdrawals when the money is just untouched, okay? So that we really see how that money is growing. It's not, growth is not, skewed by deposits or withdrawals. Okay, so anyway, so here, it's 11, 12, you have one deposit, X, otherwise no deposits, and you have X immediately before the deposit on December 1st. Okay, so yeah, there's nothing about a deposit before or after January 1st, so we assume there is none. So the period between July 1st and January 1st, that growth factor using the formula I just mentioned is 12 over 11. That becomes 1.091. Okay, and then we really only have one more period, and that's December 31st to July 1st. Okay, so after the deposit, you have 12 plus X. Right? There is no deposit on December 31st, so you end with X, and then you start off right after deposit with 12 plus X. So it's X over 12 plus X. Okay. Yeah, and then you just the time-weighted return, you multiply these two together, subtract 1. We're given that it's 1%, 0.01. So you just solve for X, multiply both sides by 12 plus X, and you'll get X is 149.63. So the numbers are similar to the homework example, the homework problem 522, but you actually get quite a bit different answer. I think X is 60 in the homework. Okay, anyway, so we do the dollar-weighted return, just like we mentioned. You take the future value of all your deposits. You start off with your initial deposit, which counts as cash out. Any other deposits you make is cash out. Any withdrawals you count as cash in, and your final, what you finally have is cash in. Okay, let's just take a look here what we have. Okay. So we have our $11. That's what we start off with. That counts as with your initial deposit. That's cash. Cash out. That's negative. You have your X here. Okay. We don't really care about this 12. It's not a deposit or withdrawal. It's not the initial deposit or the end amount of money you have. So we don't care. It's just like, it's like observing how much money you have in your account. That doesn't change anything. Doing that in between starting and the ending period doesn't change anything. Again, it's like the idea behind that is, right now stock market is very volatile. I have an account, I actually do. I probably do check it maybe more often than I should. But checking it in between periods has no relevance to, its return. It's just I'm checking it, right? Checking it 5 times a day doesn't change anything necessarily. Okay. And again, that's in between periods. You do, you start off with $11, you end with X. That's different. But in between, periods. So here's the full year that we're looking at. We start off January 1st, end December 31st. In between those two, it's irrelevant how much is in the account. Okay, so with that in mind, so the minus 11 initial deposit accrues 1 year of interest. The minus 143.63 accrues a half year of interest because that was made on July 1st, and July 1st to January 1st is 6 months. Okay, and then we have X as what we have in the account at the end of the 1 year. So you just you just do some algebra and you'll get that I is minus 0.1282 minus 12.82%. Definitely different than the book. The book, it's the book problem, it's minus 25%. Okay, but again, we're just to make clear, this 12 here is irrelevant. All we care about is what we start off with, what we end with, and any deposits or withdrawals in between. What we start off with is considered initial deposit, is cash out, it's our investment. Any deposits we make are considered investments, cash out. There is no withdrawals, so that's irrelevant, but at the end, we have X, which we got was, what did we get? I think 149 something, 149.63. So that X is what we have at the end of the 1 year. That's considered cash in. That's money we get at the end. And that's all we do for taking the future value. That's our cash flow. Those 3 numbers, 11, X and X, there's 11, 149.63, 149.63, or rather, minus 11, minus 149.63, plus 149.63, minus, plus, that's our cash flow. Okay, enough of that. Okay, so let's look at this problem here, and this is also pretty damn easy when you just think about it. It's just they kind of bombard you with a crap ton of information. I'm sure that's the point, but okay, so an investor deposits $50 in an investment on January 1st. The following summarizes the activities in the account during the year, and we're also given on June 1st the value of the account is 160. At the end of the full year, January 1st to December 31st, the value of the account is X, and we're given the time-weighted rate of return for the first 6 months the, I want to emphasize something real quick. And this probably is confusing if I didn't emphasize this. So it's using the time-weighted method, the equivalent effective annual yield during the first 6 months is equal to the entire 1-year period, entire yield during the 1-year period. Calculate X. Okay, so what the hell are they saying there? They're saying that when you compute the first 6-month yield using the time-weighted method, you find the 6-month effective time-weighted rate of return, you have to convert that into a 1-year rate of return. You do that like we've always been doing. You square it. That gives you your 1-year growth factor minus 1. So otherwise, the problem is fairly straightforward. Okay, let's just record all of the time periods, the growth factors for each time period. Again, using the same formula we had before, the amount at the end of a period before a deposit or withdrawal divided by the amount at the beginning of the period after a deposit or withdrawal. Okay. All right. Right, so from January 1st to March 15th, and I also want to mention these dates here. These dates are a little bit different than the book's problem, but the dates are completely irrelevant. I mean, it is relevant knowing that, we're going to start January 1st and June 1st to compute the first 6 months. To compute the time, the equivalent effective yields for the first 6 months, that's very important. But otherwise, and that's the point of the time-weighted rate of return. It doesn't matter how long these periods are. You just multiply growth factors. Okay, so yeah, this first one is easy. You deposit $50 and on January 1st and on March 15th, before your deposit, you have 41. So the growth factor there is just, the 41 over 50. There is no, so when we say you're depositing 50, it's assumed that there's nothing in the account and you're just depositing the 50. That might have been a little confusing, but okay. So, right, it's 41 over 50. You start with 50, you wind up with 41 before the deposit. Okay. Okay, so March 15th to June 15th. Well, after the March 15th deposit, you have obviously 61 in the account, 41 plus 21, and you end up with 82 before the deposit on June 15th. So it's just 82 over 61. Nothing much to that one. And the rest are basically just as straightforward. I'll go over them real quickly. So June 15th to June 30th. Right? And this is important how much is in the account on June 30th, because we have to use it to compute the yield for the first 6 months. Because January 1st to June 30th is exactly 6 months. We can't use any other date. So it is very important to know how much is in the account June 30th, because the problem is telling you it's important. Right? Okay, anyway. After the June 15th deposit, you have 82 plus $81, which is $163. And on June 30th, the account has $60 in it. There's no mention of deposits, withdrawals. You assume there are none. Right? So it's just 160 over 163. All right. And we got two more. So this is definitely a pain in the ass problem, but it's really not that bad. Right. So June 30th to November 15th. So right before the deposit, you have 177, and then you start off with 160, so it's just 177 over 160. And last but not least, on November 15th, after the deposit, you have 177 plus 77 is 254, and you end up with X. Okay. Again, no mention of deposit or withdrawal, so there are none. So it's just, well, it's just X over 254. Okay, so for the first 6 months, well, we just multiply these three together. The first 6 months, because again, January 1st to June 30th is the first 6 months. That gives you 1.082. So like I said, you have to square this, subtract 1. Sorry, just square it to get the effective growth rate for the first 6 months. Sorry, for the equivalent effective yearly growth rate for the first 6 months. Subtract 1 to get the equivalent effective yearly rate for the first 6 months. And that's 0.17072. 17.072%. All right, now we're basically done. Do the same thing for the whole year. You get 0.004713x minus 1. You're given these two are equal, and you're done. Solve for x. Yeah, so like I said, I think these problems are pretty straightforward. If you just follow the simple formula for growth factor I gave you, and for dollar weighted of return, it's really not that bad to just set up the future value with respect to simple interest equals 0. I think it's easier than these convoluted. I mean, the formulas aren't too bad in the book, but there's just a lot to memorize, and like I said, I'm pretty sure there's an error in one of the formulas, but I don't really want to go over that because I don't think the formulas are even worth it. So okay, and like I said, I might do a last video on yield curves for anyone who's interested. Certainly nothing on the last exam on yield curves, but I don't know if I'll do that. Not much time to do that, but anyway, if this is the last video, then well, I hope you enjoyed the course, and don't forget about evaluations. It's your chance to tell the university if you absolutely hated your professor and wish ill harm to him or her. That's a bit extreme, but it's your way to tell the university if you just disliked the course, or if you liked the course. It's your way to do your professors a favor and tell the university, hey, this person did a great job. So yeah, do them. They don't take much time. And all right, so long, stay safe, and yeah, Friday is it. And you'll get your quizzes back soon. I put up solutions to the quizzes, the last 2 quizzes. The last quiz you'll get back either probably Monday or Tuesday. Probably Monday. All right, take care. Bye-bye.